This is the basic structure of the case for the new homebrew transceiver. You see the trim here, 20mm by 3mm thick aluminium, two pieces bent around, and the four uprights, 130mm each, made of 20 by 20mm 3mm wide aluminium angle. These are joined by four pieces going from front to rear. That's 20 by 10mm, 1mm thick, and four pieces forming the corners in across the top of the cage. So I've now attached to the case the VFO section and the TFT meter. These are attached to the case using some screws through the top members. One thing you have to be careful with when building a homebrew project is you need to be able to remove modules or components out of the case without pulling the whole thing to bits. So it's very important when you design or build something that you make sure whatever it is you have to get serviced on, that it can be removed almost on its own. In this case, the VFO is held by some screws across the top. Once those screws are released, it will pull back and just simply pull out. So you don't have to pull the whole thing apart just to get to the VFO. The ability to remove a module from the transceiver without disturbing the rest of it also applies to, for example, to the TFT meter. This is held in by a couple of screws up here. Just undo the screws and the meter pulls back. I'll just give you a closer look at the display. There's no signals feeding it, so it won't show any levels or anything, but it just does signal strength, RF power, reflected power, and a few things like the compressor settings, power supply voltage, current, date, time, temperature. That comes from a real-time clock. And being a TFT device driven by an Arduino, you can also program it up if someone wanted to display, for example, a spectrum across the screen, or Morse code, decoded Morse code, or digital data. This particular display will also have show pictures quite well too, so if you've got slow scan coming through, you can switch it to the slow scan mode. This is a view on the underside of the case, and I've just put some modules here to show how the rails will be supporting the modules. These are mostly receiver modules, RF preamps for 3 bands, H mixer, which I'm experimenting with, crystal filter block, and the intermediate frequency amplifier. And down here I've tucked in the audio amplifier. This is the back of the VFO, this is the rotary encoder, and the TFT meter is in there. There will be controls along here, so there's a bit of space left for the front panel controls. Moving in closer, here's a closer look at the modules. That's the mixer, the H mixer, crystal filters, the IF amplifier, AD603, and across here we have the 3 preamps, 80, 40 and 20, separate preamps. There we go. This is a view in the top half of the case. These boards lie on the same rails as the ones you saw on the bottom of the case. This one is the AGC amp, product detector, BFO, and these 3 are transmitter modules which I haven't built yet, balance modulator, microphone amplifier compressor, and transmit mixer. On the inside at the back there'll also be a power supply fitted, and these little things here are power distribution circuit boards which distribute the power to the various modules. Here you can see the back of the VFO, and all these relays are relays that activate various modes such as sideband mode, frequent band, they're switching the different band RF preamps, etc. The low pass filters for the PA. The PA and driver will sit on the back panel with the heatsink sticking out. And here's the back of the TFT meter with the various trim pots for the different inputs. I'll just go in closer there. There's a whole pile of each of the signals going to the TFT meter need to be adjustable. There's the back of the VFO system. We have 3 outputs: a direct output from the phase lock loop, module, and then a output for the transmitter and an output for the receiver through a buffer amplifier with sufficient power to drive the H mixer, and the transmit mixer is actually a diode mixer, diode ring mixer. There's the power supply. It's just sitting there at the moment. It's going to sit on the back panel. So that's what it looks like. There's some relays there which are transmit receive, which come on and off when you go from receive to transmit, to switch 12 volts and 10 volts from receive to transmit. And some little boards, there'll be a few of these, which accept an input and then distribute power to the various modules. There's a bypass capacitor and an LED to tell you that that particular voltage, that might be, for example, 12 volts transmit receive. This one might be 10 volts receive only, and so on. There's a few of those. So that gives you an idea. There's still a bit of room left in this case. Between here and the top there'll be a speaker here somewhere, and a fan on the back panel to blow over the PA stages. So a closer look at the back of the VFO with all the switching relays and the feeds going off to the various things that need to be switched, like the BFO crystals and the preamplifiers. Go. This is a side view, and you can see the programming port on the Arduino on the side, so you get access through the side panel. And you can see those boards, mainly the transmitter boards sitting on the rails, and then you can see there's a fair bit of space above the rails. Here's a closer look at one of the corners with the various holes, some for the future, one at the front. There we go. This is a printed template of what the front panel is going to look like, where the knobs are going to be. This template will be used for drilling the various holes into the aluminium panel, and also for producing the labels photographically on a inkjet printer. Here we're just testing to see if all the bits and pieces will clear the various metal bits and pieces inside. So for example, that particular there, the microphone plug, needs a little bit of metal taken out. So if we take the template off, we'll see there's we've milled out a small section down here. And on the other side, where there's a switch going, we've allowed for the nut on the switch to be clear of the side, plus a little bit a bit milled off the rail, so that the back of the switch will fit. Same on this one here. Just little bits and pieces that, if you don't do it before you finish the rig, you end up having to dismantle that bit of metal, taking it to the workshop, because you can't do that in the rig and get metal filings everywhere. So there's a view with the covers on, the two covers I made today, and you can see I've left a gap there so the aluminium panel can be removed. You'll notice it gives you access to the programming pin on the Arduino. The programming for the TFT display is through the top, so if I take the cover off, you'll see that there it is down there. So that will also power the Arduino when you're programming. You don't need to have the transceiver switched on. However, you will need some signals to test that you've programmed it correctly. So these panels just lift off, like that, and you can get access to quite a lot of the bits.